So now let's solve a simple problem on RLC series circuit. So here we have solving problems. Okay, here we have an example. Find the impedance and the current in the RLC series circuit below. So here we have an RLC series circuit, they're connected in series. And we've been asked to find the impedance and also the current in the circuit. But the first thing we're going to do is to write out all the things we've been given. So here we have the voltage at the source is equal to 100 volts. The frequency of the source is 20 hertz. The resistance of the resistor is given as 2 ohms. Inductance of the inductor is given as, let's say 5 henries. The capacitance of the capacitor is 3 microfarad. Is 3 microfarad, which is 3.0 times 10 to the power minus 6 farad. You see. So the first thing we're supposed to do is to write out the formula for impedance in an RLC circuit, and that's the square root of R squared plus bracket inductive reactance minus capacitive reactance squared. But we were not given inductive and capacitive reactance, so we have to find them ourselves. So what is the formula for inductive reactance? It's 2 pi FL, and that is 2 pi multiplied by F is what? 20 multiplied by 20 multiplied by 5, and that gives us 2 times 5 is 10, 10 times 20, 200, and that gives us 200 pi ohms. And then capacitive reactance is 1 all over 2 pi FC, which is 1 all over 2 pi multiplied by 20 multiplied by 3 times 10 to the power of minus 6. So we take this 10 to the power of minus 6 upward, and so we have XC is equal to 10 to the power of 6. Yes, once it goes up it becomes positive, and then divided by 2 pi multiplied by 20 times 3. 3 times 5, 3 times 2 is what? 6. 6 times 20, that's 120. And so we have 10 to the power of 6 divided by 120 pi. Now, one of these zeros will take one of these zeros away. So we now have XC will give us 10 to the power of 5 divided by 12 pi. Now, 2 into 12, that's 6. 2 into 100,000, that's 50,000. Divided by 6 pi. Of course, we can still divide further. 2 into this, we have 1. 2 into 50 is what? 25. Sorry, 2 into 6 is 3. So here we have X, he becomes 25,000 divided by 3 pi ohms. Of course, if you have your calculator, you can take it even further to get an even simpler answer value for the capacitive reactance. So now let's put our answers into this equation. So we have the inductance, so the impedance becomes R squared. What is R? The resistance is 2 squared plus we have 200 pi minus 25,000 all over 3 pi squared. You see? So first of all, let's solve. So here we have 3 pi. This becomes Z is equal to, that's the impedance now, is equal to the square root of 4 plus bracket. Okay, first of all we have 1 into the whole of this gives us 3 pi times this, we get 600 pi square minus 25,000 all squared. So we have 600 pi squared minus 25,000 divided by 3 pi squared. So of course you can carry it on from here. If you put ohms, you can carry it on from here with your calculator. You should be able to get a very simple version, a very simple answer or value for the impedance in the circuit. Okay, now when you have what do you call it? Okay, the next question is find the current in the circuit. Now remember from Ohm's law that current is equal to voltage all over impedance. Now the voltage of the source is 100 divided by the impedance, which is the square root of 4 plus 600 pi squared minus 25,000 over 3 pi squared, then multiplied by that's it, ampere. So if you do all of this, you should be able to get your answer in ampere. So if there is any question, please let me know, or you can go back to the very start to see what we did.